Oh, so hello Chinmay. Sure, come fast. Uh, Samarth, if I want to convert nitrobenzene into aniline, what are the options?
Sir, SnHCl or FeHCl.
SnHCl, FeHCl, or
Sir, I think we can use H2 in presence of alcohol.
in in presence of catalyst, nickel, platinum, or palladium, right?
Palladium and ethanol.
Correct. And which one is preferred?
Sir, SnHCl.
FeHCl. Why FeHCl?
Yeah, yeah. Sir, HCl is initiated like with small amount of HCl.
The, the reason is because we can take iron scrap,
Hmm.
which increase surface area, and then HCl is consumed in a little amount because it is produced also. Okay.
Okay. Huh.
And then what is ammonolysis? What happened in ammonolysis?
So this reaction has taken place in the sealed tube.
At what temperature?
So 100 degrees Celsius.
100 degrees Celsius. And what happened during the reaction?
So ammonia reacts with alkyl halide and the nucleophilic addition reaction takes.
Nucleophilic substitution reaction. So, example, if ammonia added in the alkyl halide, what will be the product? If ammonia added in the alkyl halide, what will be the product? Alkylamine. Primary, secondary, tertiary, or quaternary. But in this ammonolysis occur in aqueous condition or alcoholic condition? Guys, am I not audible? Oh, they have some network issue. Yes, Samarth. Alcoholic condition or
Sir, alcoholic condition because finally we remove water.
we remove water? Yeah. And if you take amide, what will happen?
Sir, amide with
Alkyl amide.
LiLH4 we get amine of extra carbons. Sir.
Know that we get with RCN, nitrile, extra carbon, right? In amide itself, there is a carbon, so number of carbon in amide remains same, but in cyanide you can increase by one.
So
Success.
there also doesn't it remain same? Not the main chain, but
Yeah, you can. Example, in this case, there is a increase in one carbon, but logically, if you see, functional group have this carbon and same number of carbon, but in case of nitrile reduction, what happen? Ki it can be produced from RX, alkyl halide. So alkyl halide was having one carbon less. Amide addition, if you are doing, then again it is possible. But usually amide are the good stable compound, right? Some hydrogen bonding is also possible. Correct?
yeah.
move to the yeah. So move to the next topic, Gabriel Phthalimide, very popular for the board and of course for JE and NEET. Here we always produce primary amine, only for primary amine, only for primary amine, and you can see here primary amine. Okay. Second, phthalimide. Phthalimide react with alcoholic KOH, and what will happen? H2 will be removed. Why we use alcohol? To remove H2O. Now, guys, tell me everywhere you can link the concept of alcohol, what we studied in the last class. You will remove water, and if you remove water, you will get potassium salt. Next, if you add alkyl halide, KX will be removed. You will add R. This is an alkyl phthalimide. When this react with the base in the aqueous solution, so what will happen? It is actually ONA will be added to the nitrogen, and R will go with the my NH2. In doubt?
No, sir.
Why we cannot make aromatic primary amine by this method? Because if you take benzene ring, you know aryl halide do not undergo nucleophilic substitution reaction according to haloalkane haloarenes, right? In this case, you have to take benzene, correct?
Mm.
Because here we are adding alkyl halide. If you take benzene ring in this case, and then you try to add, then this bond will not break due to the partial double bond, right? Any doubt?
Yes. No, sir.
And last year
Substitution.
in the board exam, ditto same assertion reason was given. Aromatic primary amine cannot be prepared by Gabriel Phthalimide synthesis. Reason, aryl halide do not undergo nucleophilic substitution reaction. Ditto same assertion reason last year. Very popular reaction, guys. This one, very popular. For your competitive exam is extremely popular. Hofmann Bromamide degradation reaction. Extremely popular. You can mark this as 10 star. Extremely important. So Hofmann was the scientist who prepared this. Again, you are making the primary amide. When amide react with the bromine, but one interesting thing is you can take anything, whether you take aqueous or ethanolic does not matter. Okay, so you can take any of this. Correct. Why ethanolic it is adding? Because you have to remove water, but ethanolic is preferred because you want to remove water. What will happen in this case? Guys, am I audible?
Yeah, sir,
Yes.
you're audible.
So, though this look like you have to remember the product, but you will understand it's always about how you break down into positive and negative, and that's what I always prefer. Here, example, you have here you have two Br, bromine, bromine, and then four NaOH, 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 and NaOH. Tell me, guy, isn't it possible to remove two NaBr because of highly stable salt? Removal of two H2O molecule because again stable molecule. Isn't it possible to remove? Correct.
Mm.
Now you have two sodium available, two oxygen available, and one CO here. This Na2CO3 is highly stable molecule, right? What is the remaining? Yes or no? Do like people try to memorize the reaction, but it's as simple as that. Whichever is the stable salt possible to form, it will form. 2 NaBr, 2H2O, Na2CO3, famous product, like stable product. Remaining is amine. Okay. So solve this question. And remember, all of you have to write notes during the class. I will check in the end. Only then I'll end the session. Write notes during the class, proper notes. This should be your final notes. You are not supposed to read NCERT again. Do this question. Done. This first reaction we already did in the last class. Done, guys. In both the situation, you are increasing one carbon, right? So what you can do in that part? By the way, one interesting thing is you have amide here, same amide you have here. But if you do reduction, then there is like one carbon extra. But in Hofmann Bromamide degradation. Am I audible, guys?
Yes, sir.
Yes.
Okay, so in first situation, you can add NaCN or KCN and then reduction and it will form amine. Make sense? Second situation is also same. Understood?
Yes, sir.
Done.
Sir,
Yeah.
sir, in bromide degradation, we had a question, sir.
When? Last week or this
Yeah,
week?
sir. This week's test.
And what was the question?
Sir, RC double bond O and D3, sir.
R C double bond O
And D3.
and D. Oh wow. Same Br2 with 4 NaOH.
Yes, sir.
And it will ND2.
Sir, the answer was NH2.
It was NH2.
Yes, sir.
Okay. So, and that's what I said, keep 10 star, 100% you will get question in every test. This is very, very, very popular. Gabriel Phthalimide, you don't have any any other reaction.
Hmm.
So it is unique. Gabriel Phthalimide is easy to remember. But Hofmann bromamide degradation look normal. There is nothing special in this reaction. But still, in many conversion, it is used. Many conversion. So very popular reaction. Focus especially on this Gabriel Phthalimide. Solve this question. In first propane amine you are producing C3H7NH2. How is that possible? C3H7CO NH2, right? In presence of Br2 and 4NaOH. Yes or no? None. Make sense? And amine that produce benzamide. Amine produced by benzamide aniline. Yes or no? None. These were the two answers. See, here it was having three normal carbon and amide, so butanamide. And second, aniline. Any doubt, guys?
No, sir.
What is this? Benzene convert into aniline. First, you can do nitration, nitro is added, and then reduction. This is produced, right? This first part. How benzene is converted into N dimethyl aniline. This N dimethyl aniline. So CH3 from the benzene ring. How is it produced?
Sir, adding two more methyl chlorides.
First, same thing, and then methyl chloride. First process is ditto same. You will add one more step. If you add 2 CS3 Cl, what will happen? Benzene ring and CS3 and CS3. Make sense, guys? Here, chlorine is replaced by amine, right? Any doubt?
No,
No, sir.
sir.
Physical property are easy. Lower aliphatic amines are gases. Of course, lower member are gases. Higher member keep on adding mass, so become liquid or solid. But fishy order is important, correct? And when you take aniline or other aryl amine, because they are heavy molecules, so they are colorless. There is no fishy order in the higher member. But if you storage them, they become colorful. Why? Because they will react with the atmosphere oxygen. Correct? This rule is common. Ki lower member are water soluble because they can form hydrogen bond with the water. But higher member, more mass increase, solubility will decrease, right? Alcohol are more polar than amine. Why? Because they can easily form iron. And of course, you know this extremely strong hydrogen bonding compared to amine. Jordan, why alcohol have more stronger hydrogen bond compared to the amine?
So because there's intermolecular hydrogen bonding.
Yeah, but why not in amine?
Amine because what is it's I mean it should be there, but it's weaker compared to alcohol, no?
Why?
I don't remember why, so
Chandana,
I'm not sure, sir.
Barinder, Samarth.
Sir, electronegativity of nitrogen is less.
Exactly, electronegativity. Electronegativity in case of nitrogen is 3. In oxygen is 3.5. So oxygen is very strong. Fluorine is strongest. That's why maximum strong bonding will be present in HF because maximum electronegativity. Got it? So in case of primary or secondary amine, there is intermolecular association hydrogen bond. Correct? But it will be more in case of primary amine. How is that possible? Samarth, if you compare primary amine, secondary amine, and tertiary amine, where you will see maximum hydrogen bonding.
primary no, so
Primary.
Yes, correct. Why, Jordan?
is it something to do with the alkyl groups?
Now, because in primary amine you have maximum number of hydrogen,
Okay,
RNH2, two hydrogen here, R2, NH1 hydrogen here, no hydrogen. Understood?
yes, sir.
That's why tertiary amine do not have any intermolecular association. Why? Because no hydrogen with nitrogen. Right? Any doubt? So this is the order of boiling point. Chandana, what is the reason?
So because of more hydrogens present in primary.
Exactly. Primary means more number of hydrogen. More number of hydrogen means more hydrogen bonding, strong, higher boiling point. Correct? Uh, Barinder, boiling point of amine, alcohol and alkane is almost same. Why? Give me one. हेलो. अच्छा, बुक होगी. दूसरा भी ना की 5 तारीख. हाँ बिल्कुल. हाँ न्यू है आपका. चलो ये काम तो निपटी. सफाई के तो 4 1 लाख दे होंगे. चलो ठीक है. और जो अगर मान लिया अगला दिन बारात जावेगी नहीं और कई लोग रुकवाने हो तो फिर 2.5 महीने तो रुक है बारात खातर. बारात सॉरी बारात जो जावेगी उसके लोग. हाँ ठीक है फिर. चलो फिर उसका इंतजाम हो जाएगा. ठीक है कर दे. चलो. हाँ वो तो करवा दिया अभी दे जाएंगे फीस. ठीक है. हाँ चलो. ना करी को नहीं करूंगा मैं क्लास कर. ठीक है. हाँ मैं बात कर देते रह फोन. हाँ ठीक है. जरूर. हाँ मतलब होना तो जरूरी है अगर मैं बढ़िया हूँ तो. हाँ ठीक है. ना मेरी माँ भी कहती है तेरे का कहते मम्मा का होना तो जरूरी है. ठीक है. हाँ यह तो कहने वाली बात है कई मुझे और कभी फोन उठावी इतना तो बंदा बिजी को नहीं होता. हाँ ठीक है मैं फोन करता हूँ. हाँ चलो बढ़िया फिर तो. ठीक है. ना वो तो क्या ना बोलो. ठीक. चलो. हेलो गाइस एम आई ऑडिबल.
Yes, sir.
Yes.
Yeah. Boiling point in case of amine alcohol alkene are almost same. What is the reason? Because mass is same. Boiling point mainly depend upon the mass. Correct. And that's why example if you see here. No, wait. It is not almost same. Example, here you have primary amine. So you have maximum value. Okay. Alcohol more than the amine because we said ki hydrogen bonding will take place. Understood? And other example here you have secondary amine. That's why less than primary. And in case of tertiary amine, it is minimum. And the lowest in case of alkane. Correct? So primary amine, secondary amine, tertiary amine, and this is alcohol. Understood? So this statement is wrong. No, not wrong. It's just given key for same molar mass it is given, right? But remember, maximum for alcohol, then primary, secondary, tertiary, and minimum for the alkane. Very important. Understood? Any doubt, guys?
No, sir.
Anybody have doubt in this?
No,
No,
sir.
sir.
Good. So we know nitro in case of amine, nitrogen and hydrogen have some difference, and that's why amine are reactive. So if Anybody ask what is the reason for the amine reactivity? Because electronegativity difference. Example, if you take chlorine have same electronegativity, so reactivity will be less. But if you take HCl, will be highly reactive. Why? Because of the difference in the electronegativity. Make sense? Same thing. And here number of hydrogen in case of primary tertiary amine is different, but all behave as nucleophile. Barinder, why amine behave as nucleophile? Because when nitrogen have unpaired electron on it, it can be donated, right? So it will attract nucleus positive charge. Make sense? Samarth, we know amine are basic, react with the acid and form salt. How to identify the acidic character of alcohol or phenol?
The stability of conjugate base ion.
Yes. So they should react with metal
So they
and
should
release
give H
hydrogen
plus
gas,
easily.
right?
Uh,
If they react with metal and release as positive ion, then you will say ki they are acidic. If example if you take alcohol or if you take phenol and it react with the sodium metal or magnesium or aluminum, any metal, what will happen? Salt will form and formation of hydrogen gas. Same here, C6H5O negative Na positive and half hydrogen gas is produced. Correct? So this is the proof of the acidic behavior of the alcohol or phenol. How? Because they are releasing hydrogen gas. Correct? Same way, if you take alkyl halide, they react with the acid, then it means they are base because acid and base form salt neutralization reaction. In doubt, same react with the alkyl nature. If you it react with the strong base, what will happen? If salt react with the strong base, what will happen? Again, primary amine, water, and HX, like NaX, right? Jordan, where this reaction was given, Jordan,
Yes, sir.
where this reaction was given?
Uh, Cumin, coming, no, not cumin. So what mixing? Diazonium chloride, no, sir. I talk about.
Second preparation reaction of this chapter. Do you remember this exactly same reaction was given there?
Yes, sir.
Is this correct?
Yes, sir, it is.
Salt react with the base and it will form ammonium, then water and salt. And next, same thing ditto given here. You should know exactly where in the NCERT what is given. So we know amine salt are soluble in water, but they are insoluble in the organic solvent like ether. Understood? And that is one of the reaction how you can separate amine from the non-basic organic compound. Why? Because if you take amine, make there a salt, it will be soluble in water. Other non-basic organic compound are insoluble in water. Understood? And Samarth for J, this is extremely important because it was never asked in NEET as of now. In future, it is definitely possible, but as of now. Understood?
yes.
Okay, how we can separate amine from the other? If you take amine, make it salt and soluble in water, and it means it is amine. Other non-basic organic compound, they will be insoluble in water. Understood? Amine, because have unpaired electron, so they can donate electron, they can act as Lewis base. Like in coordination compound, ligands are like Lewis base, metal are Lewis acid. Do you remember, everyone? Yes or no? Ligand are Lewis base, central metal atom are Lewis acid.
Yes, sir.
In case if you have any ligand, this situation, so ligand are Lewis base because they donate electron. Metal are Lewis acid because they accept electron. Same here. Because nitrogen can donate electron, it can act as a Lewis base. Okay. So when amine react with the water, it will form ammonium salt and iron. And if you calculate dissociation constant K, what is its value? Product by reactant. Product divided by reactant. I will write in the bracket product divided by reactant. This is the formula we will do in the equilibrium. So if water go to another side, this same thing will be known as dissociation constant for base. So you should know in or this equilibrium chapter, Kb is equal to K into H2O. Same way, Ka will be equal to K into H2O. For acid, you will take Ka. For base, you will take Kb. Any doubt, guys?
No.
And pKb will be opposite to this, same way how you do pH is equal to minus log H positive concentration, right? Right? Same way, what will be pKb? Minus log Kb. So if you have large value of Kb, then pKb will be less, and more Kb, strong base. Understood? So remember this rule I'll write here. If Kb is more, then pKb will be less. And if Kb is more basic. And if it is more basic, less acidic. Do you remember GOC we did, Parinder? Same thing. And you can compare with Ka. If you have more Ka, pKa will be less, acidic character will be more, basic character will be less. More Ka, more acidic. More Kb, more basic. Any doubt, guys?
No, sir.
This will be really helpful overall in my chapter. Previous alcohol, phenol, ether, carboxylic acid. Okay. The same thing. Electron withdrawing group increase acidic character, decrease basic character. Donating group decrease acidic character, increase basic character. And this table make you one of the most important like marks fetching topic. This table and examiner ask many more questions. This is not sufficient, but this is basically required. You should know not number but comparison. How? Because you have to remember one basic thing. Secondary amine is most basic. Secondary amine is most basic, then primary, then tertiary. Okay. Secondary amine is more. Example. In this situation, if you understand what will happen, hydrogen is normal. R is electron donating group, benzene electron withdrawing group. Which one will be most basic?
The second one, no, sir.
Second one,
Then the first one.
and then minimum.
Then with the third option.
Imagine, because here you have less value. Here it will increase. Here normal, neutral. There is not much difference, right? So maximum 2, minimum 3. Done. Okay. So why? Because aliphatic are stronger base because of the plus I effect. Plus I. Aromatic are less basic. Why? Electron withdrawing nature. Understood? See this. Just compare. Don't remember the number. In first case, you have normal methenamine and there is a given value. But if you add one more alkyl group, then you know basic character will increase. Logically, it will increase. That's why pKb less, Kb more. Any doubt?
Yes.
Then, even in this case, you can see you have primary amine, 2 donating group. Then definitely B will be more than A, right? B will be more than A. Why? Uh, mm, I will write separately in the end. Then if you have two options CH3 and H2, and second option CH3, CH2 and H2, which one will be more basic? Which one will be more basic? It's easy to say this one
Second one. Yeah.
because more alkyl group. But if you have this CH3, CH2, NH2, and then CH3, NH, CH3, which one will be more basic? Why? Because secondary is more basic than primary. Any doubt, guys?
No, sir.
No, sir.
Yeah. So
So, comparison of secondary and ammonia.
secondary and
Ammonia.
ammonia. Ammonia will be the least. Ammonia will be the least.
Okay.
Okay. Secondary is always greater. Out of primary and tertiary, which one is greater? It depends which group. If you have small group like CS3 only, then what will happen? Then uh, primary will be more compared to the tertiary region. Hydrogen bond will dominate. And if you take big group like this ethyl group, what will happen? Tertiary will dominate. Why? Plus I effect. When tertiary plus I effect is dominating, in primary, hydrogen bond is dominating. Any doubt? And based on this, you can take all of this comparison. If you see this E part, in case of E, N ethyl ethane amine, so both secondary is highly stable, correct? And in case of F, N and I ethyl ethane amine tertiary, so secondary is always greater than whether it is primary or tertiary. No problem. So E will be greater than F. Any doubt? Benzene amine will be very low because aniline electron withdrawing group. If you add here methane, then it will be more. Makes sense because donating group. Now it will be considered as primary amine. So H will be more. Along with the aniline, if you add 1 methyl or 2 methyl, definitely 2 methyl because electron donating group increase basic character. So you will 100% get question on the basic character. Remember, secondary amine is always most basic compared to secondary or sorry compared to primary and tertiary. Any other point I missed? Yes, this is really important. This table is every. Even in your competitive exam, you will get 100% question from this. That's why for acidic and basic character, you have to practice more questions. Okay. Why? This A is most basic because secondary is always higher. And here more donating group. So that's it. Okay. So I will add last point from this chapter. Key, if you see secondary, tertiary, primary. Yeah. So if you have this CS3 NH2 and then no, I will add one more thing. CH2. Here you have CS3 and this is NO2 CH2 NH2. Which one is more basic? First one.
Yes, sir.
Yeah, sir.
Why? Here you have electron donating group.
NO2 is
Electron
with.
donating group increase basic character. Withdrawing group decrease basic character. Correct. But one extremely important point. If you have CH3, CH2, NH2, CH3, CH2, N, H, and then again CH2, CH3. We know easily this is the one, correct? But remember, if you have option key CH3, NH2, one option, CH3, NH, CH3, and CH3, N, CH3, CH3. Which one is most basic out of these three? 1, 2, 3. Definitely 2 will be always greater. Then first, then third. Why? Because if you have small molecule, then primary is given top priority. But if you have option like CH3, CH2, and H2, here CH3, CH2 twice NH, and CH3, CH2 thrice N. Which one will be most basic? Samarth.
The second one, I think.
Second, then because heavy molecule, in this case, main factor is plus I effect. Here main factor is hydrogen bonding. Secondary is always great. But among primary and tertiary, which one is great? Why here primary is greater than tertiary? Hydrogen bonding. Why here tertiary is greater than primary? Inductive. Any doubt?
Yes, no, sir.
Okay. So anybody have doubt in this? In 2 more class, I think we will try to finish this chapter.